Hi, students. For the study guide, this is question number 1. So we have our 4 coordinate points. Question number 1 asks us, what is the domain of the relation? So the domain, it's all x values, and we can think of our x values as our input. So our domain, so all of our x values, if you guys remember, if we have a coordinate point, that's just x comma y. This is our input, and then this is our output. So all of our x values, or our domain, is going to be, well, I need to enter this from least to greatest. So all of my x's are -8, 6, 2, and 6. So entering that from least to greatest, I would just enter, well, -8, 2, and then 6. So some of you are entering 6 twice, but in set notation, once you have that number, that's already, once you have that number in that set, you don't have to write it again. So that would be your final answer. So for number 2 now, instead of our domain, they asked us for our range. So our range is just all of our y values, or our outputs. So our y values, remember it's x comma y. So our y values would be 7, 3, -2, and -1. Entering that from least to greatest, though, that would just be -2, comma, -1, 3, and 7. All right, so problem number 3, it asks us if the relation is a function. So let's go back what it means, or let's go back to the definition of what it means to be a function. If I have a function, each x has only one y. So let's go ahead and try to check that with this problem. So if my input was -8, I would have an output of 7. If my input was 6, I would have an output of 3. If my input was 2, I would have an output of -2. And once again, if my input was 6, I would have an output of -1. So right here, we have the definition. Let's see. Function, each x has only one y. Well, we have something where it makes it not a function. I have my x, which is 6, and it only has to have one y, or one output. But you can see that we have two different outputs, -1 and 3. So, so it says, if not given x, that makes the relation not a function. Well, the x that makes the relation not a function is 6. So that's all you'd have to write for that answer. All right, so question number 4 asks me, what is the domain of the relation? When we think of domain, remember we think of our x values. So we think of our x-axis. The domain, we think of, well, where do we start, all the way to the left, or all the way to our left, furthest to the left of our graph? Where does our graph stop? And I can see it stops it right there at maybe 2. And then I also ask myself, well, where does it go? All the way to the right, too. And some of you might say, well, maybe this stops at 14. But remember, if this goes all the way to the edge of our graph, we just assume that goes on and on forever. So if you guys remember interval notation, the reason why we're doing interval notation for these continuous graphs is because now we don't have just points, we have a continuous line. So that's why we use interval notation instead of set notation. So with interval notation, we start with our leftmost point, just like inequalities, and we go to our rightmost point. So our leftmost point is 2, and our rightmost point would be positive infinity. With this chapter, we always use a bracket for numbers and then a parentheses with our infinity. That's our final answer. All right, with number 5, we think of our range. So if you guys look at your notes, when we think of the range of our graph, we start from the bottom of our graph and we go all the way to the top. So the bottom of our graph, well, remember this line, it continues to go further and further down. This graph never stops. So it gets lower and lower and lower. So technically there isn't a bottom to this graph, and it goes all the way down to negative infinity. So our first point is always the bottom of our graph, and the second point is always the top of our graph. Well, same line of thinking. This just keeps on growing and growing and growing to positive infinity. So that's what we write. And that's our answer. All right, so number 6 asks us if the relation is a function, right? Yes. If not, given x, that makes the relation not a function. Oops. I don't know why that's there. Okay, sorry. I was just looking at the study guide, and I accidentally typed out something. But anyways, number 6. So when we think of coordinate points, we think of inputs and outputs. Let's say my coordinate was maybe 6, 2. 6, 2 would be right here. I go to the right 6 and I go up 2. So I know that my input is 6 and my output would be 2. Let me just write that. That's my input and my output. If I have my input as 6 again, though, it doesn't have to just be 2. My output could also be down here. I could go to the right 6, and then instead of going up this way to that point, I could also go to the right 6 and go down this way to negative 2. So yeah, right now I have an x, and it's just so happens that it's a coincidence that it's the same as number 3, where our number 6 gives us our 2 different y values. But I hope you guys can see that, well, 7 would also work because it would give me maybe a y value of 2.1 and then also negative 2.1. And then maybe right here, 3 would work as well too, because 3 would give me an output of 1, and it would also give me an output of negative 1. So either of those points would work. But if you enter 6 into formative, that'll give you a correct answer. All right, number 7. This graph is getting a little bit messy, but we can still go ahead and use it. So number 7, it goes back to function notation. So if you guys think of function notation, let me just write this out. Function notation. Remember, we have our f of x is equal to maybe x plus 3. If I have f of 4, that just tells me that I simply just replace. This is my input, so I input that into my relation, and I get 4 plus 3 is equal to 7. So whenever I have something that says f of whatever number, I know that whatever number goes in there is going to be my input. So with this problem, it says that I have f of 3, and they're asking us what that's equal to. Well, 3 is my input, so once again, let's just relate this to coordinate points. If I once again went to this point 6 comma 2, let me just write that. 6 comma 2. 6 would be my input, and my output would be 2. So this is asking me, what if my input is 3? What would be my output? So if my input is 3, that just tells me, well, this is how I would look at it. I would try to go 3 to the right on the x-axis, and then I would see where does my graph, or where along my y-axis I would have to move up to get to my graph. So I went to the right 3, and I would have to move up 1 to get to my graph. So that's one of my outputs it could be. And if you notice, also -1 is my output. So yeah, it could be either 1 or -1. Either one of those answers would work. So if you guys see this line right here represents wherever on my graph my input is 3. But of course, we only care about these 2 points because that's what our graph tells us to. All right, for number 8, they want to know what f of 6 is. So another way I could think of it is, if I go to the right 6, because that's my input. My input is my x value. I go to the right 6, 1, 2, 3, 4, 5, 6. And then I ask myself, well, how many times do I need to go either up or down to reach my graph? Well, I can go up 2. So f of 6 could be 2, and that would be that point right there. Or I could also go down 2 points to get to this point right here, -2. So 2 or -2 would work for that answer. All right, so number 9, they tell us what our output is. So they tell us f of x is equal to 3. Well, so they tell us our output. They're asking us what is our x, or what is our input. So it's kind of the reverse order. If we had a coordinate, we want to know this, but they give us this. So I need to move across, or I don't know how many times I have to move across. But after that, I need to know, I know I go up 3 points. So I guess this sort of point is off my graph right now. But I know right here, my y is 3. And then if I see on my x-axis, well, I'm above x is equal to 11. So right here, that would be 11. So my input is 11, and my output, exactly what they told us, my output is 3. So yeah, so our answer would be 11. All right, for number 10, they actually, I think it was 10, yeah. For number 10, they tell us that our output is now -3. So I would try to see, well, where's my output -3? Well, that would be, once again, it's right below 11. Right there. So since my x is equal to 11, that's my input. If I have an input of 11, my output could also be -3. So yeah, number 10 is 11. All right, so number 11 asks us for the domain of this relation. Once again, we always start with our furthest left point. So let's see, if I have my graph, I keep on going left, all the way left, all the way left, all the way left, all the way left. I see that I continue on to this point right here. I continue all the way to over here. So a lot of you are saying that your left point is -5 or -6, sorry. Well, you're correct that on our y-axis that would be -6. But for number 11, we're thinking of our domain. So we think of our x values. And right here, our x value is 0. So our interval goes from 0, then all the way on the right, well, it goes all the way until where our graph stops over here at 5. So yeah, 0 to 5 is our domain with brackets. All right, so with domain, we think of going from left to right, but with range, we want to go from bottom to top. So the bottom of my graph would be over here, and that's where it's x is equal to -6. So the bottom of my graph is -6, and the top of my graph, well, some of you keep saying it's here maybe, but I know my graph goes further than that, up, and it goes all the way up until right here at 3. So that's how we think of range. -6 to 3. All right, number 13. Some of you might know this, know the trick, the vertical line test, or you can use the pencil test. If I guess, let me choose something skinnier. If I move my pencil from left to right across this graph, and it doesn't touch my graph at 2 points for a single x, I know that it's a function. So if you can see this, my pencil never touches more than 2 points at once. It only touches 1 point. So number 13, yes, that would be a function. Yes. And then number 14, given the graph above, what is f of 3? Well, once again, f of 3 is my input. So my input is 3, that would be right here. And well, how do I get to my graph? Well, I would just have to move up 3. So moving up 3, that's my output. Yeah. So what is f of 3? It's simply 3. All right, number 15, similar problem. They tell us what is f of 1. Yeah, so on my graph, I guess I didn't draw it clearly, but if you guys go ahead and see on your graphs, if my input is 1, that tells me it's going to be right here, and my graph would have to move down 1 to reach my graph. Once again, you'll be able to see that better on your assignment. But yeah, if f of 1 is equal to -1. You would just have to insert or type in -1 on formative. All right, so number 16, same line of thinking. What is f of 5? Well, my input is going to be 5, so 1, 2, 3, 4, 5. And you see at that point, in order to get to my graph, I would just go down 1. So f of 5 is -1. All right, I did my best to draw number 18. But anyways, or sorry, number 17. So number 17 asks us for the domain of the relation. Well, once again, with domain, we think of from left to right. But since this graph is sort of going to the end of the paper, we can assume it goes on and on forever. So yeah, this graph will just, remember with domain, we think of left to right. This graph, even though it looks like it's going diagonally, we only care that it's moving all the way to the left. It's keep on going to the left. So it's negative infinity is our point all the way to the left. And the same thing happens with this. Even though it's going down more, it's still getting slowly and slowly more positive. So that'll go all the way down, or all the way to the right, to positive infinity. All right, number 18. What is the range of the relation? Well, the range is going to be the same thing. The bottom of our graph, well, this doesn't stop growing, or this doesn't stop going. So the bottom of our graph is negative infinity, And this also doesn't stop growing. So the top of our graph is positive infinity. All right, with number 19, if the relation is a function, once again, you can use the vertical line test or the pencil test. You pass the pencil through this graph, and if the graph doesn't touch more than 2 points at once, or if the pencil doesn't touch the graph at more than 2 points, it passes, so it would be a function. So yeah, number 19 is yes. All right, number 20, they tell us that our input is 4. So we go ahead and count 1, 2, 3, 4. And our graph is, let's see, our graph is beneath this. So right here, we go down 1, 2, 3, 4, 5. So that means our output is negative 5. Number 21 says our input is 2. So once again, we count 1, 2. And where does our graph go? Or how do we get to our graph? We have to go down 1. So our output is negative 1. All right, for number 22, once again, it's backwards. They give us our output. Our output is 3. So let's look on our graph where our output is, or where our output is 3. And that's just going to be, well, 1, 2, 3. That would be right there. So if we ask ourselves, what's our x? Well, right there, x is just going to be 0. Yeah, so our answer for number 22 is just 0. All right, for number 23, they give us these 3 functions. Remember, these letters just mean the function name. This is just f, this is just g, and this is just h. And the x is just our input. Whatever we see on our problems, we just replace whatever number goes in here. We would just replace it with wherever we see x's over here. And the same is for g and h as well. So our first problem, they say g of 3. Well, anywhere I see x on this side of my function, I'm going to replace that with 3. So we get g of 3 is equal to, well, absolute value of negative 3 plus 2. Well, absolute value of negative 3 is just a 3 plus 2, so that's 5. All right, so for number 24, asks us what h of 7 is. H of 7. So once again, all I do, whatever I see as my input, I replace my x with that input, wherever I see it. We just get 26 minus 3 times 7. So you guys know that would just be 26 minus 21, which would just be 5. All right, so our final answer is 5 for that one. With number 25, this one sort of gets a little trickier, but we're just following what it means to have a function notation. They tell us that our input is m. So literally wherever we see m, or wherever we see an x on this side, we replace it with the letter m. This would just be m squared plus 2 times m. And then we can't combine this, or we can't add this because this isn't like terms. They do have the same letter, but remember we need the same exponent as well. So this is your answer for number 25. And then for number 6, they ask us, well, what's f of 9? Well, up in there, I'm going to replace my x with 9, so that's 9 squared. And I'm also going to replace my 2 times x with 2 times 9. So we just get 9 squared, that's just 9 times 9, that's just 81. And then plus 2 times 9 is 18. Then adding that together, we just get 99.